Hi there, Professor Monty. Let's look at an application of an exponential problem. This time it's interest compounded continuously. All right, so the formula for interest compounded continue is usually given as A equals P e to the RT. Now, they just oftentimes just call this the PERT formula. Sometimes it's just the generic exponential growth formula. P equals P sub 0 e to the KT, where P to the 0 is the initial P value. So whatever this P is starting at. Well, in this formula, A is for the amount at the end, P is for the principal or the amount at the start, R is the rate of interest written as a decimal, and then T is the time. It has to be the same period as rate. So if the rate is monthly interest, this has to be number of months. If it's annual or yearly interest, which it usually is, this is number of years. Okay, and that E is just that irrational number 2.7 something that's in our calculator. Okay, so we're going to use this formula to do this problem. $5,000 invested 4% compounded continuously. How much is in the account after 12 years? So we're just using the formula A equals P e to the RT. Well, the amount, that's what we're looking for. P is the principal, that's what we start with, 5,000. E raised to the rate is the 4%. Put that 4% as a decimal, 0.04. And that's 4% per year. I didn't write that, but that's what we're assuming. And then it's for 12 years, so that's times 12. Now, on some calculators, you have to put parentheses around there to make sure it does the 0.04 times the 12 before it just does the e to the 0.04. So if your calculator raises to the exponent naturally, you don't need the parentheses. The parentheses won't hurt, though. But this is just a calculator problem now. So I'm just going to put this into my calculator. So I've got 5,000. And then times e to the power, so I have to do second ln, and then 0.04 times 12. Again, put that in parentheses if you need to. I get $8,080. And to the nearest penny, 37 cents. Okay, so very straightforward. It's essentially a calculator problem, which you know the formula. When will the amount be $10,000? Okay, now we know the amount. So again, A equals P to e to the RT. We know the amount is 10,000. We know I started at 5,000. We know the interest rate is still 0.04. We just don't know the time. Okay, so remember to solve this, I need to get rid of that 5,000. It's not part of the exponential. That just gives me 2 equals e to the 0.04t. And then remember to solve that, we take the ln of both sides. So we get ln of 2 equals ln of e to the 0.04t. The ln and the e cancel each other out. They're inverses. I just get 0.04t equals ln of 2. And then I divide by 0.04 on both sides. And I get, well, that's going to be approximately, let's plug that in, ln of 2, close parentheses, divided by 0.04, about 17.3 years. That's going to be my time. And notice if you have a doubling time formula, that's what we did. We doubled our money from 5,000 to 10,000. The doubling time formula is always ln of 2 divided by whatever the interest rate is. Anyway, we get our answer. So that's how you do these compound interest problems. And they just take a little practice. But once you get the hang of them, they're pretty cool.